Remember, we have already done two Poisson distribution and then we did one binomial distribution. So we have to do one more binomial distribution. That's how it works. And we have also done two hypothesis tests in this paper. So a telesales operator is selling a magazine. Okay. Each day he chooses a number of people to telephone. The probability, so this is binomial, so the probability that each person he telephones buys the magazine is 0.1. So we can say this is P equals to zero point 0.1. We don't know how many people, but I guess selling a magazine, this could be the n number of magazines, that could be n. So each day he chooses a number of people to telephone. Okay, suggest a suitable distribution to model the number of people. So model the number of people, that is the definition of the random variable. So number of people who buy the magazine. So remember that. So these three are what's important. So let's write this down. So question number A, suggest a suitable distribution. So it would be binomial distribution. Always define the distribution. So x equals to number of people who buy the magazine. And we don't know what the value of n is, so it's going to be n comma 0.1. Question number B. On Monday, the telesales operator telephones 10 people. So we know 10 people are called. Find the probability that he sells at least 4 magazines. So number of people who buy the magazine. So 4 people bought the magazines and n equals to 10. So let's write this down since we haven't put the value of n yet. So this is going to be 10 comma 0.1 and we have to find the probability at least, that means greater than or equals to 4. So if we calculate this, it would be 1 minus probability of x is less than or equals to 3. And let's look up the table. So we're looking for the block where n equals to 10 and we're looking for 0.1 as the probability of success. So this is the column and this is the block we're looking for. And we're looking for less than or equals to 3. So it would be 0.9872. So let me write it over here. 1 minus 0.9872. And that turns out to be 1 minus 0.9872, 0.0128, 0128. Question number B. Question number B says, calculate the least number of people he needs to telephone. Remember, this is the random variable. No, this is not the random variable, because the number of people we need to telephone, that is n. This is definitely n on Tuesday, so that the probability of selling at least one magazine, this is the random variable, number of magazines sold, is greater than 0.95. Again, we have seen a question like that before. So probability is not equal to, the probability is greater than. So what's happening is that this information, the least number of people who needs to telephone, this is the value of n. So again, n is unknown. So what we have to find ultimately is the value of n. So let's do this. So question number C is going to be, let me write y over here. Again, n is unknown, the probability of success is 0.1. So what we have to do is we have to find the probability, it's written, at least one person. So y is greater than or equals to 1 and the probability is not equal to 0.95. The probability is greater than 0.95. This is an irregular question. So what we have to do, we cannot look up the table because n is unknown. Previously, we used the Poisson distribution to look up the table. But in this particular sum, n is unknown. So what we have to do, we have to use the PDF formula. So since it is greater than or equal to 1, we have to make it cumulative. 1 minus y is less than or equals to 0. So greater than 0.95. So this would be minus y is less than or equals to 0 greater than 0.95 minus 1. So this is minus, less than or equal to 0 is the same as equals to 0, and this would be minus 0.05. If you cancel the negative, what it would be, y equals to 0, this would be less than 0.95. Now we know the rule for binomial, so y equal to 0 is going to be nc0. So nc0 1 minus p to the power n minus 0 p to the power 0 less than 0.05. So that means nc0 is 1, 0.1 to the power 0 is 1. So 1 minus zero point 0.1 is 0.9 to the power n less than 0.05. Now what you have to remember for this particular sum is the rule of logarithm. Think about this. If a to the power x equals to b, therefore x equals to log base ab, then we can change the base log b by log a, and the base would be 10. That's common base. That's what we have to do. But since this is inequality, one thing you need to remember, logarithm of any number less than 1 is negative. So what happens if you write this log base 0.9.05, what you're doing is sending a negative number to the other side, because log of any negative number, a log of any number less than 1 is negative. Let me show you. So if you have log 0.9, it would be negative. So sending a negative number to the other side of the equation, the inequality would be reversed. So that's why you have to remember logarithm of a number less than 1 is negative. So n is greater than, so let's change the base, 0.05 divided by 0.9. So n would be greater than, so log of 0.05 divided by log of 0.9, and we get 28.4. 28.4. Now n has to be a natural number. That means a number that is a positive integer. So greater than 28.4 is 29, but it can be more than that, 30, 31, 32. It can be anything, but they said least number. So n has to be 29. The final question, a call center also sells the magazine. So someone also sells the magazine. The probability that a telephone call made by the call center sells the magazine, this is a different distribution, because the probability of success is now about selling the magazine is 0.05. The call center telephones 100 people. So this is n equals to 100, and p equals to 0.05. This is a completely different distribution. And since n equals to 100, you know, if n is more than 50, we cannot use the binomial distribution. We have to use a different sort of distribution. So that's what they mentioned. They have to use an approximation. We have to find the probability that more than 10 people at the call center buy the magazine. So this is the random variable. So that's what we have to do. So let's do this. So we have A equals to number of people sells the magazine. Call center, the probability that a telephone call made by this sells number of magazines sold. Magazines sold. So the distribution would be, so we have 100, and the probability of selling the magazine is 0.05. So, and the random variable is more than 10. So probability of A is greater than 10. Now the thing is, we cannot use the binomial distribution because n is more than 50. It's not in the table. So we have to use an approximation. Now we have two options for binomial. Remember, previously we have done Poisson distribution and we had only one option, and that was Poisson to normal approximation. But binomial distribution has two options. First, we have to check if Poisson distribution works. What does that mean? That means if the lambda value is within 10. So let's check. So using Poisson distribution as an approximation, So we can write lambda equals to NP, expected value, so which is 100 into 0.05. So it is within 10. So now we can use the Poisson distribution. So we can use the letter C. So Poisson 5. So probability. Remember, this is the same as binomial. It is discrete. There has to be no continuity correction. So C is greater than 10. So 1 minus probability of C is less than or equals to 10. Remember, if this is discrete, greater than 10 means 11. So we have to start from 10. 1 minus C is less than or equals to 10. So let's look up the table. So we're looking for lambda equals to 5 and we're looking for less than or equals to 10. So that means this one all the way over here, 0.9863. So 0.9863. So 1 minus that, and that turns out to be 1 minus 0.9863, and we get 0.137, 0.0137.